When we're evaluating logarithms, there's two different forms. There's logarithmic form and there's exponential form. Now log form looks like this, where you've got a log with a base of b of y equals x. Now what we can use is something called down and diagonal. Okay. Down and diagonal to really evaluate this. So the b is what comes down, and then the y and the x diagonal onto opposite sides. So I'll show you how this looks. So b becomes the base, x becomes the exponent by coming over. We have the equal sign, and then the opposite side goes the y. So b comes down, the other piece is diagonal. And this is what creates exponential form. Okay, so where y equals b to the power of x. All right, so those are the same thing. That's how you go from one form to the other. So that's an exponential form because the x adds up as the exponent. So the problems we're going to see will tell us to convert from, well, initially they'll tell us to convert from one form to the other. So for example, convert the following to exponential form. And they give us log base 5 of 7 equals x. So a quick way to do this is use down and diagonal. The base comes down, becomes 5. X comes over, becomes the exponent, and then we have the equal sign. Over here is 7. Now we don't need to solve it right now. They just wanted us to change forms. Let's do another one. Let's say they gave us log base 2 of 8 equals x. So same thing, the 2 comes down, becomes the base, x becomes the exponent, and then 8 goes to the other side. Down and diagonal. Now what's going to change is when they ask us to solve these problems. They're going to tell us log base 4 of 16 equals x. So 4 comes down, x comes over, becomes the exponent, 16 goes the other way. So when it says solve, it's asking us to find out what x is. Now we're really going to look at this and figure out what the value of x should be. So this is saying 4 to some power equals 16. So in this case, 4 to the second power, 4 squared, would be 16. So the x value that makes this true would be a 2. So that's solving for x. 4 to the 2 power is 16. Let's say again, it told us to solve log base 2 of 64. Set that equal to x. 2 comes down and is the base. X is what I'm trying to solve for. It's up in the exponent, 64 over here. So 2 to what power gives me 64? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times another 2 is 64. So overall that is 2, 3, 4, 5, 6, 2. So 2 to the 6th power is 64. All right. Now, it may get a little bit trickier when it tells us log base 7, 1 over 49 equals x. So down and diagonal, and we're starting to see this fraction here. So whenever we have fractions, here's what I want you to do. Kind of focus on the bottom number. 7 to what power gives us a 49? That would be a 2. And remember, the way that we get to bottoms is if exponents are negative. Remember, let's say we had 2 to the negative 2 power. Negative exponent puts us on the bottom, so it's really 2 to the positive 2 on the bottom, which is 1 over 4. So what's happening here is this exponent needs to be negative in order to create a fraction like this. So it would be negative 2. 7 to the negative 2 power gives us 1 over 49. So if you want to make a note of that off on the side, when we have fractions, these are negative answers. So let's see another one of these. Let's say log base 2, 1 over 128 equals x. 2 comes down, x comes over. That whole thing moves over here. So really looking, we know the answer is going to be negative because of the fraction, and then 2 to what power gives me a 128? And a little exploration on our calculator, that would tell us that 2 to the 7th power would come out to that. So 2 to the negative 7 gives us 1 over 128. All right, now eventually we will learn change of base formula, which allows us to use our calculators to solve these problems, but here we're just evaluating by hand. The thing to remember, down and diagonal, and if we have some sort of fraction involved, usually those come out to negative answers.